Imagine a shaft. The diameter tolerance is exactly within limits, and circularity is acceptable in every section. But once it runs in the bearing, there is still vibration, with tight spots in some regions and clearance in others. What is the problem? Not in the individual sections, but in how the form behaves along the entire length of the cylinder. Today, we're talking about cylindricity, the volumetric counterpart of circularity. Cylindricity is the requirement that the entire cylindrical surface must lie between two concentric cylinders. The common axis of these two cylinders is the ideal cylinder axis. The inner cylinder represents the minimum boundary, and the outer cylinder represents the maximum boundary. Relationship with circularity and straightness. Cylindricity actually defines several form controls at once. Circularity in every cross-section, straightness along the cylinder axis, and the prevention of overall tapering or barreling of the surface. While circularity controls only a single circular section, cylindricity controls the entire surface, that is, both all sections and the behavior along the length at the same time. Therefore, a cylindricity tolerance is broader in scope and more restrictive than circularity. Cylindricity becomes critical especially in the following cases: bearing housings and bearing seating surfaces, high-speed rotating shafts, hydraulic/pneumatic cylinders and piston surfaces, precision guide shafts and linear bearings, parts joined by press fit, interference fit. In these situations, it is not enough for the individual sections to be round. The same form and the same diameter behavior must be maintained along the entire surface. On the drawing, cylindricity is shown with a special symbol placed inside a circle, together with the tolerance value next to it. This means that the actual cylinder must lie between two concentric cylinders whose diameter difference is, for example, 10 micrometers. Important points. Cylindricity is a form tolerance, therefore it is not referenced to any datum. It is independent of size tolerance, and is usually chosen to be smaller than half of the size tolerance. It applies only to cylindrical features, that is, surfaces such as internal bores or external shafts. In cylindricity measurement, the goal is to capture the form deviation along the entire length of the surface. The main methods used are cylindricity/roundness measuring machines. These special instruments collect both sectional data and data along the length, and report the cylindricity error in millimeters or micrometers through dedicated software. Coordinate measuring machine (CMM). A large number of points are taken from the cylindrical surface. The software calculates an ideal cylinder and evaluates how much all points deviate from this model. In short, the more numerous and better distributed the measurement points are, the more reliable the cylindricity evaluation becomes. When cylindricity degrades, point contact occurs and bearing stress rises, life decreases, noise increases. Sealing elements are overcompressed in some regions and loose in others. Leakage occurs. In rotating systems, unbalanced load distribution creates vibration and energy loss. In press-fit joints, the load does not distribute evenly. The risk of cracking or loosening increases. Common mistakes: tightening only the diameter tolerance, and not defining cylindricity. Even if the size is correct, the part can lose its function if the form is bad. Saying, "Isn't circularity enough?" and neglecting volumetric form control. Using the cylindricity symbol but not preparing the measurement infrastructure. In other words, writing the control on the drawing without planning how it will actually be verified in the shop. When cylindricity is defined correctly, both performance increases and a repeatable, predictable production process is achieved. To sum up, cylindricity is much more than just hitting the diameter. It defines how the form behaves with respect to the axis along the entire surface. Circularity controls a single section, cylindricity controls the entire volume. Stay tuned for the rest of the series, and don't forget to subscribe and turn on notifications. Right tolerance, right behavior, right performance.